Well, hello, and welcome to Bloom Where You're Planted, supporting science and mathematical inquiry learning through the library program. My name is Dr. Brian Johnson, and I'm the librarian at Lakeside Junior High School, located in Springdale, Arkansas. In this presentation, we're going to look at how inquiry-based learning methods can be employed through collaboration with teachers to benefit all learners. We're also going to look at some science and math extension activities that were developed to help students continue to grow and build their learning in those content areas. We're going to finish up with some general suggestions about best practices for blooming inquiry-based learning opportunities for all students. So in this presentation, we're going to talk briefly about the theoretical basis. Also going to share a little bit about the school context where these activities were conducted. Then we're going to look at 2 science extension collaborations. We're going to look at 3 different math extension collaborations. Now, as I mentioned earlier, we're going to finish up with a little bit of information about some of the best practices for blooming where you're planted and supporting inquiry-based learning through the library. So first, just briefly about the theoretical basis. Historically, inquiry-based learning activities have not been offered to all students. At times, students who might not speak English as their first language, or perhaps the teachers might perceive that they lack the background knowledge, have not had chances to really delve deeply into inquiry-based learning. And as Glazewski and Ertmer note, we need to be providing these opportunities for all students and for our underserved populations to have effective inquiry-based learning and problem-solving instruction. They noted that it's a key for helping students to attain educational equity. Abdi also noted that inquiry-based learning promotes academic achievement and lifelong learning. And really, outside of what the research says, inquiry-based learning is just fun. Next, we're going to take a moment and look at the context where these activities were conducted. As I mentioned, I work at Lakeside Junior High in Springdale, Arkansas. We're located on the northwest corner of the state, up near Fayetteville. Next, we're going to look at our demographics. We have about 700 students across the 8th and 9th grades. There's about 350 in each grade level. And our population is also highly mobile. So even though we get 350 new 8th graders every year, over the course of a school year, 350 of our students will move back to another school, or maybe they'll move to another state, or sometimes they move out of the country as well. We're also very culturally diverse. Our students are about 35% Hispanic, 5% African American, about 25% Caucasian, and the rest of our population is made up of students from the Marshall Islands. In Springdale's community, we actually have the largest population of Marshall Islanders outside of the Marshall Islands themselves. And 85% of our students do receive free or reduced lunch services. In terms of how these extension activities were developed and what the need was, I'm going to tell you a little bit more about Lakeside. Lakeside is really a growth-focused school. We have a lot of our learners who come in below grade level, both in math and in their reading skills. So that's really where we focus a lot of our attention and a lot of our instructional activities. And as a result, because we had so much focus on that, we've really seen some great growth in our learners who arrive at Lakeside behind. Since there's such a growth focus in our building, and particularly on students who are below grade level, that also has helped us to identify a need that our learners who arrive at Lakeside on grade level need extension opportunities or ways for them to continue to grow. So first, we're going to look at a couple different science extension collaborations. For each of the science extension collaborations that I'm going to discuss briefly here, there'll be some information about the inquiry questions that students were attempting to answer through these activities. We'll also talk briefly about the materials that were needed, and you'll get to see what these activities look like in action as well. So we're going to look at one called homopular circuits, or these are sometimes known as homopular motors. We're also going to share a speaker dissection and a DIY speaker build that students participated in. So first, the homopular circuits. And the goal here was for students to create their best design. So this was a part of a unit that we've done on non-contact forces. And the materials that are needed for this activity are shown up here. You can see there's a battery, there's a powerful magnet at the bottom, and then we provide students with some strands of copper wire. So for the homopular circuits activity, the inquiry question students were answering was, what's the best design for a homopular circuit so it will spin at the highest speed? And students had to make a lot of design considerations. One of them was, how many different ways can we connect the copper wire to the battery? Also, does the size of the battery matter? We provide students with some C cells and also AA batteries and AAA batteries and some coin batteries. And also, does the type of wire matter? Is there a certain gauge that works better, or a certain type of wire that is most effective to create the spins that we were looking for in this activity? And also, does a rechargeable battery or a regular alkaline battery work best? So we also provide our students with some additional further challenges. Started asking them some questions about, well, how could you make a design spin with multiple pieces of copper wire instead of just one? And we also shared some work with an artist from Japan who creates homocular circuits as artwork. We'll pop out to X for just a second to show you what this looks like. Next, we're going to look at a couple examples of the homocular circuits that students created. And you'll notice that there's really a great variety of different designs that they've created here. And you can see there's quite a bit of artistic work that goes on and a lot of twisting of wire as they develop their designs. This is a really good example of some of the options that students could explore here, where we had a neodymium magnet across the bottom, and we used a rechargeable battery, and you can see the copper wire there as well. And I saved the best for last here. This is one that is probably the best circuit that I've ever seen built in this activity. Just watch how fast this one spins. Next, we're going to look at another challenge. This one we called Get Loud. I want to tell you a little bit more about this before we delve into the activity. My science team recently had a curriculum shift, and they've started to use a science curriculum called Open Sci Ed. And they actually brought me a book with 12 different objectives for their current unit on non-contact forces. And they said, hey, Brian, where can we plug in some inquiry-based extensions for this? So this is one of the ones that we developed. So we did both a speaker dissection and also a building project. And we were looking for them to learn about what's going on inside a speaker, and also how do the parts of the speaker work together to play sound through the air. And then we gave them the DIY option at the end. How can I make the loudest homemade speaker possible? So the way we did this activity was, we have a stadium seating space in my school, and we would have 2 or 3 different science classes, up to about 70 students at once, come in. And I had an old pair of broken headphones, and I put these elements under a document camera and dissected the speaker. Kind of similar maybe to if someone was studying to be a doctor, how they might do some dissection that way. We took the parts of the speaker apart and named them and talked about how they fit together and what the science is behind it underneath the document camera. And then I also had made a homemade speaker to show them. And then we did a little bit of a comparison about the materials and which speaker they thought would be louder comparatively. Would it be the headphone speaker or the one that I had made? And you'll see in the next spot, we had students actually come up and test this to see if they could hear it. And I'm going to be a little honest here, it really wasn't very loud, the first one that I made. The materials we had for our speaker, we can see there's some alligator clips there. This is just a milk jug that's turned upside down. It's going to function as the cone for the speaker. We've got some copper wire down here, and also the magnets embedded in the bottom part of there of the milk jug. That part of the activity was for all students, but then we also gave them a chance to come into the Maker Lab and build the speaker themselves. And I'm a little bit competitive. I'm actually a lot competitive. I turn it a little bit of a contest. Can you build a louder speaker than Dr. J can? And so you can see we equipped them with some safety equipment, some safety goggles, and also some gloves. We gave them some different cutting tools. We gave them a large supply of cardboard. We had all kinds of cups, paper plates, even had some Gatorade bottles, and you can see a couple of the example designs. There's one over here with a speaker cone that were included. The speaker that I originally built got to, I think, 8 decibels. But the ones that the students built really did a whole lot better than that. We had a number of groups who got up into double-digit decibels. I want to show you a couple other examples of ones. You'll notice there's a lot of iteration in their design and a lot of variety. And students really dug into this to continue to refine their designs to make their speaker louder and louder. So here's another design. See the copper coil there and the magnets making the magnetic field that allows that electrical energy to get converted over to acoustical energy. This is the best one that was made, and this one actually got up to 21 decibels. Next, we're going to look at some of the math extension collaborations, and we're going to look at 3 different ones here. First, we're going to look at one called Finch linear equation predictions, also one called Sphero versus Dragon Ball Z. Then we're going to look at one called Angling for Treats, where students extended their learning about angle measurements. The first one we're going to look at is called Fortune Telling Finches, and this is one where students were asked to make predictions to show off their knowledge of linear equations with coding. And for this activity, you may see the plexiglass that we have here. These are actually from the Maker Lab where we conducted that speaker build. And we took these big pieces of plexiglass off and cleared out the center space of the library so students could spread out on the floor and work on this. And if you're unfamiliar with the Finch robot, it's something that Carnegie Mellon University developed. And it's sold by a company called Bird Brain Technologies. They're about $100 a piece. But the company has actually done a really great thing to get their product out there. They offer a free loan program, and you can go to their website and fill out a form and tell them about how you'd like to use the robots. And they'll ask you things like how many you'd like and how many weeks you'd like to keep them. And they'll actually pay the postage to ship those robots out to you and also pay the return postage. And this turned into a really great advocacy piece because we actually did the loan program first. And then after we had worked with the robots with some classes, I was able to go back to my administration and get some purchase for the school. For the Finch linear equation predictions, the inquiry questions were, how can I use coding to make predictions about how a finch will move, and also explain the process in relation to the 8 mathematical practices? And for this activity, students worked through a series of challenges. And for each challenge, they were given some information about the power to the different wheels. And then they were asked to make some predictions about what the distance would be, or they had to work really closely with the independent and dependent variables and identify what the constants were. And then at the end, they actually get to build their own challenge as well and pass it on to some of their classmates. But on the back of the sheets where the challenges were listed, students would record their data to see if their predictions were correct. Students, you can see that's what the back of the form would look like. And they had to do some measuring here with the robots. So you can see they're using the Finch robots just to do some quick block coding. Most of the programs had between 4 and 6 blocks in them. This is a video that shows what the measurement activity looked like in practice. There's another shot of the students recording their data. The next activity I want to show you is one that we called Dragon Ball Z versus the Pythagorean Theorem. And you'll see where the Z comes in here in just a moment. For the Dragon Ball Z versus the Pythagorean Theorem, the inquiry questions were, what are the best speeds to have a robot move through the maze to form a right triangle and also a Z? And you'll see the pattern on the boards that are in the next couple slides. And also, what angles are needed to successfully navigate the maze? This activity, students used the Sphero robots. These are these softball-size round robots that will roll around on a surface and light up as they go. And in our district, we have access to a box of these, so students are able to use those. The Sphero robots themselves come with a kind of unique-looking protractor to help students make measurements. And as you can see, the students over here doing some block coding to program the robot to roll through the maze and also to turn to the different angle measures. We also used some of those science trifolds to make some practice boards for students. We had about 10 of these set up around the library, and you'll see the path of the maze that's on here in this shot, and it's a little bit better in the next one. This is the path that the robot would follow. The Sphero would roll up through angle number 1, and then it would turn, drop down to number 2, roll across to number 3 for that first triangle. Then it would roll up number 4 and all the way across to number 5. And there's the Z section before it would roll through the tunnel. And then in the very middle of the library, we had the actual test track set up where students would have the robots roll through the different angles up through the tunnel. And then we had a feature at the end where they really had to code with precision. We called that stopping on a dime once it had rolled through the tunnel on the spot. This video, you get to see what it looks like when the Sphero navigates the whole maze.
Oh, that's good. Yeah. Okay. problem is a physics problem. There it is.
Yes!
I love the response of the group at the end there. Yes! Next activity we're going to look at is called angling for treats. This is an opportunity provided through the library for our students to demonstrate their measurement skills with protractors and rulers and yardsticks. In this activity we used with something called Goose Chase. The way Goose Chase works is you use a phone or a tablet to record all of your answers, and then they get turned in directly to the teacher. And in this activity, students can either enter their answers in text, or they can do it through photos, or they can do it through videos as well. I've got a couple examples I want to show you here. And one of my favorite things about this activity is, and the Goose Chase platform, is that it gives students a great deal of opportunity to use creativity to not only solve problems, but also to come up with really creative solutions. And as a teacher, I can always provide them with some bonus points. And you'll see that in a couple of the examples we're going to look at. For this activity, the inquiry question was, how can we accurately and creatively measure and represent angles found in the library? So in this activity, we had them moving all over the library space, looking for angles and making some measurements. Here's a couple examples of some clues. For this one, they found a reading poster, so they found the measure of the angle for that side of the letter A. This was from a book of Kobe Bryant quotes. For this one, students found that Kobe's shoulder was at a 45-degree angle. Here's one, students went back, and I have my nameplate on my desk, and they measured the angle for that acute angle. Now, as I mentioned, students can also submit answers through video as well as through pictures and text. I want to show you one more example. This is of a chance we gave for students to jump over something in the library that they had measured, and we gave them bonus points if they called out the angles that were found in there. This is one of my favorite examples in this presentation. I don't think you could hear the audio of the student actually calling out the angle measure on the back of the chair there. To wrap up our time, I just want to summarize with a couple best practices to cause collaboration to bloom in your environment. Because it's true, every educational setting is a little bit different. The context is a little bit different. Through the library program, we always want to provide collaborative opportunities with teachers and promote excellent instruction and inquiry-based learning for all of our learners. So some of the best collaborations that I have are just through informal hall meetings. I'm very intentional about walking the halls between classes, and it's a really great opportunity to just go by and talk to the teacher and say, hey, what are you guys working on today? Or what's your next unit? Or what's the project that's about to come up in your curriculum? It's also important to be really intentional about attending team planning sessions. If this is with a particular grade level, or all the science teachers in your building, or all the math teachers, or the different content areas. One thing that's really key too is to just pay attention to when there are shifts in the curriculum. That activity, the speaker dissection and also DIY speaker build, that came out of a shift in the curriculum, and it produced some really great instructional opportunities for our learners to extend their learning through inquiry-based learning. And also, as we know, being a teacher is hard, and there's a lot of heavy lifting with the curriculum. The library has a really great opportunity to support our teachers and to help them with the heavy lifting of the curriculum. And sometimes blooming where you're planted means to look for ways outside of the box to facilitate teacher support. There were a couple examples in our presentation of this. We turned the library basically into a big measurement game space in the angling for treats activity, for example. I want to wrap up with a question here. We need to really consider how the library space can be repurposed for different instructional activities to help our learners to keep on growing. So thanks for being here today for the presentation. And if you'd ever like to contact me about maybe some possible ways we could brainstorm for how you might bloom where you're planted and support your teachers through inquiry-based learning for all learners, feel free to reach out to me on social media. I'm at Golden Eagle LMC on Instagram and X, and also on TikTok, or you can reach me through my email address there. But thank you so much for being a part of this Bloom Where You're Planted session today.